You should all have gotten a message that we are now being recorded. And I will just hide this. And here it is. Good. Thank you for attending this first webinar around cloud native applications, and the first one around modernizing your applications. So for those of you who don't know me, my name is Rob Jensen. So I'm a lead system engineer at VMware in the business unit called the Modern Applications business unit, but a lot of times known as the Tanzu business unit. So we got a packed agenda today. So the agenda today is all around what does it actually mean to modernize your applications. See today as the foundation for some of the other workshops or webinars we'll be having as well. We'll be talking today also about application design. How do you actually design a modern application? What does it mean? What kind of methodologies we'll be using? Then we'll be talking a bit about containers, really basic containers. So how do we actually build a container? How do you get started with that? What does it actually do? And then we'll talk about Kubernetes. So how can Kubernetes help you deploy your applications? And again, it will be pretty basic because the purpose of this webinar, at least the first one today, is around to give you an introduction to cloud native concepts and technologies. So we will really be talking about the basic stuff today. So if you're already familiar with containers, Kubernetes, etc., this might be a bit boring, and you might want to switch to skip this one and go to the next one. I won't have my feelings hurt if you jump off now. But just so you're aware, this is for everyone. This is even if you don't know anything about containers, then this should be a really good starting point, so you can start to have conversations with people and actually understand what does it actually mean to have to run things in Kubernetes, what does it do, etc. If you have questions, then use the Q&A function. So my partner in crime, Vesco, is the co-host here today, and he will be monitoring the questions. If there's anything that's really important to ask right away, he will interrupt me. But if not, then we'll take the questions in the end, as many as we can. And if for those we can, we will answer them after in mail or whatever. So we'll figure that one out. It's a minor thing. So let's get started. So what does it actually mean to modernize your application? So I've stolen some text from one of the Tanzu websites, and application modernization is all around taking your application and modernizing, updating it so it uses newer languages, frameworks, newer infrastructure, etc. It is around taking something you already have and making it more capable of using newer technologies. So why should we do that? Well, first off, we'll look at two different types of applications today. One is the shelfware that you buy that might not really fit into this. The other one is the one where you actually can make a change to it. And if you look at that, then the software you can make a change to, you probably already did quite a lot of investment in it. It's not cheap to develop software. It costs a lot of time, effort, money. And modernizing your application is a way to kind of protect your investment, but it also allows you to reduce resources. I see that actually quite a lot. I'm not always sure that I really believe that, because software never uses less resources in my opinion. It always uses more. But it allows you to increase frequency and reliability of deployments and improve uptime and resiliency. So what does that mean? We'll get back to that a lot of times today, because part of modernizing your applications is also being able to update them frequently. We were talking about updating applications many times a day, so you're able to respond to the needs, your customers' needs a lot faster. We're not talking about updating some software once every year, or once every 6 months. We're talking about maybe doing it 10, 15, 20 times a day, if that makes sense. But also still being in control, making sure that things don't break, that it's actually more resilient and reliable, etc. And that's some of the things that modernizing your applications can help with. And there's a couple of ways to do that. So I'll start by going through 3 of them. The first one is probably the one I hate the most, lift and shift. Pretty basic. You take your application, let's say it's a virtual machine today, and you move it to somewhere else. That could be the cloud. That's a common scenario, but it could also be another data center, etc. In my opinion, you're not really modernizing the application. You're doing something with the infrastructure underneath, but if the infrastructure isn't the problem, then you only just moved the problem, to be honest. If you have a problem with your application, then it's the application you should focus on. But a lot of people do that, move things to the cloud, and then, yeah, we modernize it and we'll look at it later, which often leads to something where applications being more expensive to run, and you might not get all the benefits of running it in a cloud or somewhere else. But again, totally up to you. The one I like a lot more is the refactoring. So refactoring, that's where you control everything in the application. And again, this is not for shelfware because you probably can't do that much about that. But this is the applications you might have built yourself, or at least are able to look at the code and do stuff with. So when you refactor things, then you can really make sure that you are up to date on your frameworks, that you use the underlying infrastructure a lot better, and new methodologies, etc. And this is where you can really make a change to your application. We'll talk a bit more about that, but it's also the hardest. So if you are about to move an entire data center somewhere else, this is probably not the one you'll be using for all your applications. It's probably more the first one, or maybe the one in the middle. The last one is replatforming. And replatforming is all about taking, again, let's look at this. You have a VM and you might have a database as well, also a VM in your data center. If you move this, let's take VMC on AWS as an example, where you run VMware infrastructure in the public cloud. And let's say you run VMware on site as well. Then you're able to take your front-end VM and move that seamlessly to Amazon. But you might not want to run a database anymore. You might not want to run maintain the operating system or update the database and stuff like that. And when you suddenly move things through, for example, a cloud provider like Amazon, then you can take advantage of some of this software as a service offerings they have. It could be a database that you can just utilize and connect to. And then you suddenly modernize your application a little bit anyway. If the performance of the application is equal to the performance of the database, then you might actually get a benefit of doing this. But it also allows you to do other things around that application later on. That could be things like, let's say you want to do monitoring, and another way of monitoring that application. Then Amazon might have tools in place to do that monitoring that you can utilize. You might want to do backup at some point, and that backup support is free. Then you can suddenly use Amazon's backup for that. And then suddenly you start to modernize the things around it. And there's a lot of examples for that, and that's probably more doable. But don't be fooled. It still takes a lot of time and effort to do this. But it is probably more doable. Some of the technologies we'll be talking about today. The first one, probably also the most simple one, the one you definitely all know, is cloud computing. So when people talk about modernizing applications, they often talk about cloud computing because that's, yeah, we moved to the cloud, now it's modern. It's probably not, but cloud could also be on-prem. It could also be a service provider somewhere. It could be anywhere where you can programmably consume resources that's offered to you. And that could be your own data center, and that could be somewhere external, or it can be a mix. So when we talk cloud computing, it's not only the mega clouds. The one that might be a bit more interesting is the container part. So containers, and we'll be talking a lot about containers today. Containers is a way to package your applications in a thinner shell. So you suddenly don't have an operating system to maintain. Doesn't mean you can just take any application and move it into a container and then everything is good. But it is an easier, probably more portable way to package your applications and be able to suddenly move them around, scale them, etc. We'll look at that in some of the architectural designs later. But containers is definitely part of modernizing your applications, because it provides quite a lot of benefits. And again, I'll come back to a lot of those later. Microservices. So might be confused with containers, but they go hand in hand. But microservices is more an architectural way of designing your applications. The idea is that you take every component, every service in your application, and you split out so it can be maintained, updated, operated individually, scaled individually. And that's a big part of our conversation today. So when we talk microservices, that is the concept of that. And then the last of the technologies is all around orchestration and automation. I mentioned before updating your application 5, 10, 15 times a day. Without automation, that will never be possible. So if you have to create a ticket for your networking department to add extra IP addresses when you scale your applications for the load balancer, then you can't scale 10, 15 times a day if that ticket takes 5 days to resolve. So if you need to be able to respond more faster, be able to deploy faster, you need to have automation in place. And that's some of the benefits that the cloud offers, because all the big mega clouds, they do have some way to automate, to get an IP address, to create a network segment, deploy a new VM, container, Kubernetes cluster, whatever. But you can also have that in place. You can also have that in your own data center. There's a lot of examples for that. I will go through some of VMware's and some of the later webinars here. But it's a critical place to look. If you don't have automation and orchestration in place now, you won't be able to update your applications or modernize them and take full benefit of that. So let's look at application design. So this was all the concepts around modernizing applications. Let's look at how do you actually do it. What's the methodology to use? One thing I really like is the whole continuous delivery part. If you today, if it requires you to manually forklift your applications from test to production, then you're probably not doing it right. Or at least you need to look at how you can do it more clever. I don't care what kind of technologies you use, but thinking about having some kind of automated deployment pipeline where you're able to change something, automatically build it, test it, and run it in production with all the right tests and guardrails and all of that. That is what enables you to actually modernize your applications and be more reactive to your customers' demand and be able to modernize it continuously, because it doesn't stop. So whatever technology we'll go through today and in the later webinars, try to have that in the back of your head, that being able to update it automatically is a really important thing. So the building blocks that you use can vary, but we'll look at some of those. So some of the things that you can use when you build an application today is, of course, you can have bare metal. You will probably have dedicated hardware. You will have a lot of performance, but you also need to manage the entire stack. So you need to manage the hardware, the operating system, and everything on top of that. And if you need to redeploy, then that might take some time. So what most people probably do, guessing since you're this call, you already do this, is running virtual machines. We've done this for many years. That way we only manage the operating system and everything on top of that. But we still manage an operating system, and we need to have automation in place for that. Containers, they're a bit more lightweight. A container contains the service, and it contains a file system, and that's more or less everything we need to focus on. So it's a bit lighter. It also comes with some drawbacks it's not, containers, in my opinion, can't replace everything, but it's a good tool to have. But then we also have something called functions, or function as a service. A function as a service is most of the time also built on top of containers, but the idea is you only maintain your code. And that could be a really nice thing for scheduled jobs. If you have some kind of service that runs, I don't know, once a day or every time you get a request for it, etc., then that might be part of your application design that you can use. So it's really important for me to say this is not one or the other. It's an architectural choice, and there's drawbacks to all the technologies. And just all the way out to the right, I didn't include it today, you have something like WebAssembly, etc. Also, so it gets smaller and smaller. But again, that's for another talk. So don't think it stops here. So application design. The application design I want to talk about is one that's called the 12-factor app. It's kind of the de facto standard for how you build cloud native applications. So it was built it was created in 2012 by Heroku, and the focus is how you can build cloud native web applications. And you will see some of the choices here is definitely with a web application in mind, but it doesn't mean you can't take a lot of the things that's included here and use that in your application design. And I'll definitely refer back to it for a lot of the other webinars as well, and also later in this webinar. It's going to show you what this means. So you can go to 12factor.net and see a lot about it. And I include a lot of links later today with some videos, etc., if you want to see more. But the idea behind the 12-factor app is that you have 12 different things that you should think about. And let's go through them just one at a time. So the first one, I hope you can see this out there, is the code base. Number one. What's meant there is that you should be able to be many people who can work together on the same project with different types of services, branches, etc., whatever we call them. And there's quite a few ways that you can do that, but the most known one and the one that's more or less standard is Git today. And Git would translate to enterprise software, probably being GitHub, GitLab, Atlassian Suite, Azure DevOps, and something like that. Something that uses Git, the open source Git underneath. And that allows you to be many people who work together in a structured way on the same project. And yeah, if you don't know Git today, if you've never looked at it, I definitely recommend you to start to having a look at it, because it is a core building block to everything we'll be doing later on. So the second one is all around dependencies. And every service, every component you have in your app should have its own dependencies. So that means, let's say I run a Python application that consists of 3 different Python services. Then I can't use the same requirements for all 3. They have to be individual, so I can update them and operate them individually, so they don't have any dependencies to each other. That's really important. And again, the whole idea behind this is that you split everything out into microservices or containers, etc., that you can maintain individually. Number 3 is all around configuration. So configuration should always be external to the application. So why is that? So you'll see that in a later, a bit later step here, but the idea behind this is that you test your applications. Of course you do, but how do you test an application in different scenarios? Let's say I have an application that uses a backend database. By having my configuration external, I can point to my test database when it runs in test. When I run it in staging, I might point it to my staging database. And when I run in production, I will point it to my production database. So, and by having the configuration external, I use the same components in all 3, so it is the same. It's an important thing. Number 4, backend services. Every service that we use, databases, message queues, key value stores, stuff like that, should always be external. So the application itself only includes the application, but if it uses a database, then that is an external service to that. And I'll explain more why that really makes sense later on. Number 5, build, release, run. The idea behind this is that you can't make changes in production. So every time you need to make a change, you do it in the build phase, and then a new version gets built, released, and put into production. So that's the whole idea behind this. And then you have some traceback, etc. We'll look a bit about that later on with containers. Number 6, processes. So again, this is one of the ones that is more web-based. So the idea here is that every process is individual. So if you imagine a front-end web server, let's say I have 3 front-end web servers. When I log on, it will have a cookie stored with my session in it. If that session or that cookie is only on app 1, then if I suddenly switch to app 2, then I need to log in again. So the idea is that if you scale, etc., that you have everything like that, probably hidden in some key value database in the back, could be Redis or some other service. So it doesn't include that state. That's the idea behind that. Number 7 is port bindings. And port binding is just that every service exposes its service as a port that you bind to. Don't think too much about that, not yet anyway. Number 8 is a bit more interesting, concurrency. So you need to be able to scale your applications up so they can run many applications. And that, again, going back to number 4, that you have your database and other things external. You wouldn't be able to do it to scale your things up if your database was part of your application, because you probably have corruption, etc. But suddenly when you split those apart from each other, then you can suddenly scale your applications up and down without any problems. Number 9, disposability, means that any service should be able to easily start up fast and shut gracefully down as well. So again, back to the scaling part. So if I suddenly want to scale my front end from 2 containers to 20, then I can do that quite easily. Number 10 is around that dev and production should look exactly the same. It should be the same. And again, looking back at all the other components which we've seen, that kind of makes sense, especially around the configuration part, etc. So that's what that means. Then we have a bit around logs. We'll go too deep into that, but that's a whole section around how should you log your thing, so it's a standardized way, so you can collect the metrics from everywhere, but in an easy way. And number 12 is around admin processes, how you run them against your application. I think the last 2 is a bit more advanced. If you just get the first, 5, 6, 7, 8, then you are really long way. But a more interesting thing, or more important thing, in my opinion, is the mutable versus immutable infrastructure. And what does that mean? So I've talked a bit about being able to deploy your application many times a day. And this is also called pets versus cattle, cats versus cattle, etc. Lots of different names. But the idea is that if you run a mutable infrastructure, just like a lot of you probably do in some of your applications, let's say a VM, then you have version 1, and then you want to update it to version 1.1. That's fine. You update your application, but it might leave a little bit behind for version 1.0. That might not be a problem. But what when you update it to version 1.2, 1.3, 1.4? Is that still not a problem? What if you update your application, let's say 15 times a day? And let's say after 10 days, you have a 150 versions lying behind. Is that a problem? I don't know, but it might be. So the idea behind the immutable infrastructure is that you never update. You destroy and you provision a new one. Containers is extremely good at that. That's really one of the big benefits of it. So when you're on version 1 and you have a version 1.1, you kill version 1 and you deploy version 1.1. That way you have a clean slate every time. That's really important. So let's look a bit more into the containers part. How do they fit in? So I'll skip this one a bit. But what is a container? Let's just take the basics one. Compared to a VM, A VM is something running on a hypervisor. It has a full operating system, applications running on top of it. It has virtual hardware. It doesn't know it's virtual. All of those things. Container. It's a container. It runs on top. It says Docker in this in the blue one here. If you use that, but it is a container runtime. It can be other things than Docker. Docker is a commercial product, so that uses container runtime. But a container on top of this is a service and a file system, and you can run many, and they're fast at starting up, etc. But let's dig a bit more into them. So what are the benefits of them? And I'm a bit biased in this one, but I wanted to just really get down to the basics and show, if I want to deploy a new application on a VM, what kind of steps would I go through? You might not use all of these steps, and some of them might be more automated than I show here, but all the red ones are meant to be the automated task. So the first thing you'll do is you will deploy an operating system, or you will install it. I hope that is an automated process. If not, go fix. It should be. The second one is that you need to configure your operating system to support that application. It might be that you add another disk, some more memory, and stuff like that. But pretty basic things. And I'm guessing that's probably not an automated thing if this is a custom application. And that's pretend it is. Then you patch it. I really hope you do, and I hope that's an automated thing as well. So it's up to date in case your template isn't up to date. Then you install the tools you need to support your applications. You might have some, you might not. And again, if they're not included in the base image. Then you install dependencies. Let's play with the Python part. The dependencies here would probably be the right Python framework, which is probably not included in your base image because this is a specific thing you're doing. Then you deploy your application and you configure your application. And then you're good to go. If this was a container, you would create something called a Docker file. And we'll look at that in a bit. And that takes some time to create that. And that is a manual task. But it is a step-by-step description on how do we actually build this so everything is automated when you're done with it. So when you're done with it, you build a container, and you deploy it. That's it. So in my opinion, a bit more simple and automated than the VM part. So let's look at how you would update it. So you would probably patch the operating system. I hope you would, so it's up to date. Then you will update the dependencies. Let's say there's a newer version of Python, etc. That's probably not as an automated thing. And then you will update your application. If this was a container, you'd push new code, and then you would probably automate it, build a new container, and automatically deploy it. And that's kind of the beauty around containers, is that automation is such a big part of that. So when you do an update, you probably have a pipeline or something else that does all the steps all the way to production automatically. And I talked a little bit about Docker files before. So what is that? And we'll go into demo in a second, so you can actually see how this works. So a Docker file is a step-by-step description of the application I want to run. And I've just taken a real simple one here, a Python application. And what I'm doing is I'm starting in the first line from, it says what's my template that I want to use. And I use the official one, the official Python one, but it has a label that's 3.12.0b for Slim Bullseye. That is a specific version. If I deploy this container today, it would have the exact same patch level as if I deploy this in a month. Nothing will change. If I want a newer patch level, I'll choose a newer version of it. So this means it's the same every time I run it. That's really important. In the next one, I select where I want to work. I want to work in a directory called applications. And then I copy everything from the folder I'm in to the container. And then I run a command, pip install, pointed to a requirements file. That requirements file is part of the files that are being copied. And then I select that I don't want any cache or anything left behind. So build it. And then the last line, the CMD line, is when I run this container, I want you to run this line, this command, which is Python, pointed to the application file, which is also the second file that I copied when I built it. So let's see how that looks in a demo. 2 seconds. Oh, stop sharing. Not stop sharing. Sorry about that. I will go to like this. So let me make this a bit bigger. Let's kill this. So what I got here is my directory with Docker. So, and I got a little step-by-step things that I want to do. I hope this is big enough, or else, Vesco, this is when you interrupt me and tell me to make it bigger. So I got a couple of files in this directory. So I got the application file. This is simple Python. You don't need to know what it does. It doesn't really matter. I'll show you in a second. Then I have the Docker file, which is exactly the one I showed you before. And then I have a requirements file. And in this case, I'm running a web server called Flask, and I want to use exactly this version 2.3.1. So all I need to do if I want to build it, I need to be in the right directory. And I can see I am. And then I need to run a command. Normally, I will just run docker build and then give it a name and point it to a Docker file in this directory. But I'm running on an ARM computer, a Mac M1, and the endpoint where I'm going to show this later is running x86. So in this case, I actually need to build it for both platforms so it works, or else it won't work. So I need to run something else, Docker build X, and I give it a name. Note that it's called registry.tanzu.dk. This is where I'm going to place it. Put it in the webinars folder. The container is going to be called app, and this is the first version I'm creating. And then I select which platform I want to run it, and the dot in the end means that it will use it in this directory. So if I run this now, then it will build exactly what it said in the Docker file. So that's, I have some of the dependencies cached from earlier, so it's pretty fast. But I can see now that it's created. That was it. If I want to run it, I need to expose a port. So I'm just doing a Docker run. Then I select the port. In this case, it's port 5000. And then I point to my container. And if I click on this, then it says it is now running. And I should be able to click here and say follow link. And you will see here, Tanzu webinars demo is working in version 1. So that's basically all I needed to do. I can stop the container. And then I want to push it to my registry. And I'll show you when we get to the Kubernetes part why I want to do that. A registry is a place where I can store my containers so that others can pull it. So it's, if you use vSphere, then it's just like your contents library. It's a place where you can store your templates. So I've now pushed this, and we'll look at it a little bit later. So let's try to change something now. So the first thing I want to do is I want to take my requirements file, and I want to say, I know the Flask is now 2.3.2 instead. And then we can take the application and say, now we are running version 2. So I've just saved these two files. I'll go back to this one, and I will go down and I'll say, I want to build a new version. And I run this again. Note the only thing I changed was the label here in the end. Shouldn't take too long. You can see it's pulling probably pulling the new Flask binaries. And then I want to push this again also to my registry. And it's just pushing all the changes. And if I run it, I run exactly the same command as before, just with a 2. Click on this. We go down here and we click follow link. Then it says Tanzu webinars demo app is working in version 2. So I now have 2 versions that I can run. And if I cancel this and I change this to 1, click it again, and I refresh this page, then it goes back to number 1. So I suddenly have 2 versions I can mix between. So that's part of the whole deployment. When you modernize your applications, you will start running containers. Then when you build a new version and you start by running that new version, if something is wrong, it's always easy to get back because you have a traceability. You have previous versions that you can easily get back to. So I will cancel this, and then I'll go to my retro sheet because I want to show you a bit about what it is I've actually done. Just need to refresh it here and go to my webinars page, and I'll make it a bit bigger so you can see it. So in this case, you can see that I have my webinars app. It contains 2 applications here. It actually looks pretty bad. Can I hope you can still read it? Give me 2 seconds. Okay, it looks really bad. Sorry for that. I don't really know how to fix that. But the interesting part here is that we have the 2 versions here. You can see the tag version 1, version 2. But by actually putting this into the container, I also do vulnerability scanning. And you can see version 1 had 98 vulnerabilities, but version 2 only have 97. I don't know if that's a lot or how that is, but it doesn't really matter. But it's just, we don't just store the containers, we also scan them, and we actually react to when we scan them, if you are able to deploy them afterwards. There's a bit of security built into all of this, and I can even click on it, and I can see all the CVEs right now in this, and I can see if it's fixable. It normally has a little icon here. So this is where I'm storing my applications, and again, note that when we get back to the next part. So that is containers. But let's try this. If we move a bit further, because this is really good for running things on one host. And again, if you're only going to run one container in your environment, then you probably don't need Kubernetes. But if you're suddenly a lot of people working together on the same projects, you're starting to build microservices. You want to use some of the benefits of using a container orchestrator, then Kubernetes is definitely something that might be able to help you. And see Kubernetes as the robot here in the middle that can maintain all the different services and help you update them, maintain them, etc. But what is Kubernetes? So Kubernetes, open source project, and it's a platform for managing and automating containers. It's able to deploy applications really quick. That's definitely true. It can scale your applications really fast, and we'll show an example of that in a bit. It can seamlessly roll out new features. And one of the things that you can do in Kubernetes, you saw the version 1 and version 2. I could, if I run this in Kubernetes, I could actually tell it, only update 25% of your containers. Check that it actually works. Then update 50%. Then update 45%. Something like that. You can just update slowly your application until you reach 100%. So you do it in a more predictable way. And if something goes wrong, you can easily roll back. That's some of the features that Kubernetes has. It says here it's stolen from another slide. It optimizes use of hardware. I don't know about that. I just think it uses a lot of resources, but it's probably it's for a good cause. So and again, this is a container as a service thing. So let's look at what is Kubernetes. I'll try to really put it down to the basics. So Kubernetes cluster consists of one or more masters, and a master is that's the controller. That's the one that contains that manages all the different configurations you have, all the containers. It knows the configuration you apply to. It knows where it needs to run everything, etc. But it's not running any resources. It's not running any workloads. You use your worker nodes for that. So the worker nodes is where the real magic happens. That is where everything is running. And on top of that, we run pods. And I've just been talking about containers, but in this case, we're talking about pods. So a pod is the minimum concept we have in a Kubernetes cluster. And it consists of one or more containers, a network, and file system. So this is my entire application I can put into this. I can also run my application in multiple pods, but you could put everything into one pod, and Kubernetes is able to scale this out and make sure that your pods is running on where resources are. So, and for the ones on the call that is used to vSphere, this could look a lot like a vCenter. The workers could also look at it like ESX servers, and the pods could look a lot like VMs. So it's not that different when you look at it like this. The difference comes in a part of the complexity. So if you follow social media, Twitter, etc., you will see a lot of people saying Kubernetes is hard. And I tend to agree, and I really tend to disagree. And the reason for that is Kubernetes can be hard. Kubernetes can be extremely hard. Kubernetes is a distributed platform, and distributed platforms are, by definition, more complex. But it doesn't need to be. So if you want to see all the components, if you want to do everything in hand, then Kelsey Hightower, a former principal, I think, from Google, has a GitHub repo where he shows exactly how to build Kubernetes doing everything manual. And that is hard. But there's a lot of vendors like VMware, for example, that allows you to be able to deploy a Kubernetes cluster by the click of a button, maintain the state of it, make sure that it's running at all times. It doesn't need to be hard to do that. So, and again, when I say it's easy, if I say that, it will be easy as building your own cloud. Because there is a lot of prerequisites that needs to be in place. You need to have network in place. You need to have storage in place. You need to have a lot of things in place. It's the same with vSphere. If you run that, you need to have network. You need to have switches. You need to have storage. You need to have a lot of things. But a lot of those are just common to people who used to use vSphere. And this will be the same once you get used to it. An important thing around Kubernetes is don't treat it as VMs. Don't treat it as something that's long-lived. Treat it as the cat versus cattle. Treat it as something that if something breaks, you kill it and you deploy a new one. Mostly for the worker nodes, of course. But treat it like that. Treat it as something you can easily replace, update, etc. So, and again, the Tanzu portfolio helps a lot with that, but that is for a later webinar. Another change is that everything is done using API. So you will see me in a second use some command line to deploy my applications. But that command line, all it does is it translates my commands to an API call. So everything is done using API. I always find it funny when customers say, we are API first. Well, if you're on Kubernetes, yeah, you are. So it's, and then another thing, Kubernetes is not just about containers. Kubernetes runs containers, but it also has a concept called CRDs. And CRD is a custom resource definition, which means that Kubernetes can manage anything you define. So if you want Kubernetes to manage, I don't know, some strange thing, you can create your own CRD and use it for that. And a good example for that is certificates. So if I want to use certificates in a Kubernetes world, we won't do it today, but we will definitely do it later. Then I can install a component called Cert Manager, one of many. And I can hook that up to my CA where I get my certificates. And just by a small, a couple of lines of YAML code, I can say, give me a certificate with this URL, with this specification, and I'll get that. And that's quite powerful. And suddenly, Kubernetes manages my certificates for me. I think certificates is a hard thing, but I actually don't think it is when you use it in Kubernetes once you got it set up. So let's look at how we can take the application that we just created before and deploy it to Kubernetes to kind of see the change. So in this case, I will do like this, and I will go to section number 2 and open here. So if I say, okay, get nodes, normally you say kubectl, but I got a short or alias that, so I only write K, just so you're aware. In this case, my Kubernetes cluster consists of 3 control planes, as talked about before, and then 5 worker nodes here. So, and you can see the version, you see how long it's been up, and all of that. So, and if I look, I need to go into, let me see. Sorry, I need to go one back. Yes, and go to 1, and then go to, yeah, it's the right folder. Sorry, that's my mistake. So in this case, I have 2 files. I have a deployment file and I have a service file. The deployment file, as you can see up here, describes my application. So it describes, I want to do a deployment, give it some names, some tags. This is the image that I want to run. The registry Tanzu DK, webinars, app version 2. So that's the one we created before. I also set some memory restrictions, limits, and I tell it to expose port 5000. So if I say k/f and I say deployment, then in 2 seconds, it will say it's created. Okay, get pods. Then you will see that it's about to create a container here. It got this strange name. If I run it again, it should probably be up and running. So I'm now running this this application. It is now running on Kubernetes. It pulled it from my registry where we pushed it to before, and it's running right now. But I can't access it. And why is that? Because I haven't exposed the service. So a service is where I define how to actually communicate with this pod. And in this case, I give it a name, selector, stuff like that, but I tell it port 5000. That's also the target port, and I want the type load balancer. So we just say, okay, apply is service, then okay, get C. Then you will see I now have a new demo app service. It's the type load balancer. It got an internal IP, but it doesn't got an external one because it's pending. I'll just do this again. And then suddenly I got an external IP. This is all it took for me to talk to a load balancer, tell it to expose this application. I didn't need to do anything else. I didn't need to talk to any network people. I didn't need to talk to any firewall people or anything. I can do it here. So that's quite powerful. And if we take this and we say, find my browser, and I'll point this in, and then we say port 5000, then you see the demo app is working in version 2. That's nice. So this one is now running on Kubernetes. But that's all it took. But it's just one pod. So I run, 7 servers to run one pod. That doesn't really make sense. So if we say get pods, again, you see I have one running. So if I want to scale this, and that's part of what we talked about earlier, then I'll go up here and I'll say replicas. Let's say, should we say 10 instead? So when I change this YAML file to 10, I say apply if and say the deployment. And then what I do is I apply the new configuration, and Kubernetes will look at the changes and say, hey, now we went from 1 and now we're up to 10. Let's see what it says here. Okay, get pods. And now it's actually starting to deploy multiple containers. Give it 2 seconds, and you should see that all of them are running. Okay, create container error. I don't know why it says that. Most of them are running anyway. So I don't know what's the problem with these one, but they are all running right now. And if I go back to my application and I say refresh, then it continues to work. And it's the load balancer in Kubernetes just chooses the one that makes more sense. So depending on how I set up the load balancer and stuff like that. But what I can also do is, and also I need to remember this command. If I say get pods, so that's wide, then you can actually see here, these are all the pods that is running right now, but you can see which node they're running on. So all of these are running on, again, I only have 5 nodes, so it scheduled them on different nodes, but they are now split out on all the different nodes that I'm running, all the workers that I'm running. So I have some uptime. If I pull the plug on one of my workers, Kubernetes will say, well, I lost 2 containers. I need to redeploy them on another one. So I maintain the state that you described to me in your deployment file. And there's a lot of extra things you can do in that. So, but that's kind of the basics around Kubernetes. We'll dig a lot deeper into this. But I just wanted to show that we went from a Docker file where we built a container, we pushed it onto a registry, a place where we can keep our containers. And when we went to Kubernetes and said, hey, this simple web server, deploy that in 10 versions on your Kubernetes cluster and expose it to the outside world. And it's now running. That's pretty neat, if you ask me. So going back to the last part, this was the last thing I had in this webinar today. So the next time, which will be on Tuesday, we'll look at how we get started with GitOps, DevOps, or DevSecOps. And that is basically how you automate everything we just done today and automate that. So I don't have to build my containers. I don't have to do all the things we did manually today. All I need to do is focus on pushing my code. We also talk about what new skills and tools are needed because it does require some new skills and some new tools, Git being maybe one of them. What about things like databases? How do you run that? Because if you Google, can I run databases on Kubernetes? You will probably find a lot of articles saying, oh, no, you can't. But that is definitely not true. And it changes all the time. But there is a caveat to it. So let's dig into that. And how do you monitor your applications? Let's take a look at that as well. So until the next time, I will post this recording. I'll put this on the webinars.tanzu.dk so you can see that. I will also link to this presentation in PDF format so you can see it if you want to. And I included some links here. So if you want to dig deeper into the 12-factor app, then there's a really nice video for it that I actually spent some time when I did this presentation looking at. Look at Docker, look at Kubernetes, maybe look at the Tanzu website, and you can also register for the next event if you think this was interesting. And if you just want to reach out, say hi, connect, etc., then my contact details are up here. If you scan the QR code, then you get directly into, I don't know, my GitHub repo, my LinkedIn profile, etc. You can just connect. I'm always happy to talk. And with that, if Vesco is still alive, is there any Q&A? You went awful quiet there. So no open questions. Yeah. So Søren, you talked about API, but I want to show kubectl, which I see as a CLI, and that is correct. But kubectl translates the command I use to an API. There's a REST API for that. So you can also use. I've seen examples, and I can see if I can link to some of it. But you can use REST API directly to it. But kubectl is just a translator for that REST API, nothing else. So that is the API. So I hope that answered it. And Sibisco is typing something. Well, if there's no more questions, then thank you for participating. It's been you've been awesome. A lot of people has attended. So and I hope to see a lot of you next time. And if you have any feedback, etc., reach out. Twitter, LinkedIn, etc. I'm happy to talk. So have a nice day, and I hope to have the recording up later today or at the latest tomorrow. So thank you. Stop the recording here.